grasshopper as a Rhino plugin that was developed about 11, 12 years ago, I guess, by David Rutten. Since then, this kind of interface of these components having an input and an output, this was adopted by Revit and Dynamo and 3D Max. I mean, a lot of softwares have adopted this kind of graphic interface of coding, which is very intuitive and actually is a design in itself, a design process in itself. And once you get the ability to or the interest to start playing around with it, there's quite a lot of design possibilities within it. So this is essentially how it works. Yeah, you have these specific components that you plug in data or information, and this data is either representing of some sort of geometry or a number set, and I'll go over that in a second. Now, a key aspect of basically the geometry and the manipulation of geometry in Rhino Grasshopper is the vector. And I'm trying to kind of jump back to the early modernists in that this is all from the Bauhaus as well. These are diagrams by Paul Klee, and he was obsessed with vectors as a kind of, and he took it obviously before the invention of modeling and computers, but he saw it as a kind of transfer of energy from one place, from moving one element from another. And I think most of his pedagogical kind of approach to teaching students were based around the vector. I don't know if any of you have seen this before, but a lot of his kind of teachings, this is taken straight out of one of his lessons in the Bauhaus, but it's very relevant for the way Grasshopper works, is basically how a vector moves a point or a line or a plane and creates from a point, it creates a line and then a volume. So from 1D to 2D to 3D. And this is quite ahead of its time because he, in a way, this is 100 years ago, he foresaw everything that basically this interface does now as a means to create a design. And at the time, they saw this as a kind of a new design that would shape a new architecture in the world. So the first thing that we have to do is we have our point. So this is our a point that starts. So first thing we do is we can double click, and I just write in point, and then a component for point appears. Now I want this point to be associated to this point here. So what I do is I right click, set one point, I click on this guy, and it's green. So now we know this has a point, contains a 1 point inside. So now we want to make this point into a line. So as the diagram suggested before, we want to start moving this point and creating a line through the vector. So the first thing we want to do is create a vector. So the vector will try one y unit vector. So this is a vector using that goes up. So if we just plug that into here. Oh, sorry, you have to move it first. So we want to move the point. Okay, we want to move it there. Okay, so we saw that point has moved 1 unit up. Okay, so quite simple. Now we want to create a line. So we want to create a line connecting points. So it's quite a simple. So potentially we have this point, which is always you can hover above, and this kind of the output will tell you what the output is. So the geometry is 1 point, and then the other point is the initial point. Okay, and we have a line connecting the two. So we always can click on what we do, and then we have in green what we're actually selecting. Okay, so now we want to create a grid of points that are around this. So for this, I just type in rectangular grid. Okay, and this has quite a few inputs. So basically, to control these grids, we're going to use what's called a slider. Now, a slider is something quite common in Grasshopper. It gives you an amount of control. It's in Dynamo as well. So this is a slider. So the base slider is from 0 to 1. So we don't want that. We want it to be larger than that. So we want to double click on it and have the maximum go up to 20 and have these integers. So we don't want decimals. Okay, so now we see the slider go from 0 to 20. So we'll just plug this guy in to, this basically defines I'm going to copy this so that we can have multiple inputs. Okay, and okay, so what do we got? So we have now a associative plane, or that we can actually start playing around with. So this creates the extents, and this controls the size of each specific cell inside. So it's two sets of parameters. Now we basically want to associate points to all of these. So we can see here, we can either have them as cells, we can have them as points. So we want to, again, have a new set of points. We're going to type in points similar to this, but in this situation, see, we have a set of points arriving. So we can now control how many points. We want to maybe hide this, so we can just right click on it and type preview, and that gives us a set of points that can now be controlled. Okay, so far easy peasy, right? Good. And okay, so now what we want to do is we want to create lines out of that are associated to each one of these points. So we want the line to start from one side and actually end on one side, because we want it to rotate nice and neatly. So basically what we do, again, we use a vector. Okay, so in this case, we want the lines to be different. We want them to be on the x-axis, which is here. So we're going to use the x vector here. And move. So we want this to be associated to that. Move. So we want to change these. Basically, what I'm doing now is flattening this, because this is okay. And we want to now move all of these points to 1 unit to the right and 1 unit to the left. So for that, we use a negative vector, and we can copy this guy. So basically, what this does is okay, so we move. Okay, so basically what this gives us is what is happening? Okay, because the x should be on this side. So the negative should be here. And okay, now it creates negative, and okay, cool. So now we'll take this line and plug it in, one here, one here. Okay, I mean, a lot of times when you kind of plug the wrong thing, you see something crazy happening. So no need to panic. You just have to work methodically. So what I'm doing now, I'm just hiding the points so that we have clean lines that we can. Okay, so we have our set of lines. Potentially, we can start changing how they look. Now, the problem is these lines are a bit small. So what we want to do, we want to associate the size of the line with the size of the, why is that? Sorry, I've just something. Okay, so we want to associate the size of the line with the size of our, with the size of our grid. So for this, we'll take, we can actually take this and that. Okay, so see now it basically created lines that are much thicker. So we want them to be maybe a little bit. So what we're going to do, we're going to divide this number because it's a bit too big. So we'll divide it by 3, like that. Panel. Okay, so basically a panel gives us the ability to create any text, any number, and just plug it in as well. So if we plug this in here and this in here, see? So now we have lines that are nice and neat. They're associated to the size of the, so anything we change here, the lines are gonna change accordingly. So depending on the size of the grid, the lines are gonna stay the same. Is that clear to everyone? Why we did that? Okay.
Yes.
Good. Thanks, Mark. Well done. Okay, so moving forward. So now we want to start. Now comes the interesting bit. Now we want to have these lines have a relationship with the point. So how do we do that? So we basically measure the distance of each one of these points as a vector and check those vectors and see when it's the closest, we want it to have the most effect, and when it's the farthest, we want to have the least amount of effect. So what we do, we just check the distance. Okay, so this distance from, so this original point here, that's our base point, okay, to these points, which are, so we could always have a look inside and see what's going on inside as far as data. So when I click here, see, this is our data set. These are all the numbers that this is spitting out. So these are all the distances between one and the other. So we want all these distances to be nice and neat because we want it to rotate from 0 to 90, okay? Because we want the most affected to be exactly 90 degrees and the least affected to be 0. So these numbers have to be reevaluated or remapped, it's called, so that they fit in that kind of realm, okay? So that option is called a remap. So I do remap numbers, okay? So this is quite a useful command anytime you have a set of, because essentially in Grasshopper, you're working with numbers. So you want to manipulate these numbers and have these numbers changed in a very specific way to numbers that you can use for any task that you want to use. If it's solar, if it's a cost. So this is quite a useful tool to use. So there's 3 inputs here, which are important to look at. So you could always hover above the inputs and it'll tell you. So the value itself is this. So these are the distance. We put that in. Now this is the source. So basically this is a domain. So basically we have to define what is the top and the bottom of these list of numbers that we want to remap to. So we want to it's called bounds. So we basically bind this. So basically we're changing the top and bottom of this. So this basically takes the minimum and the maximum of this set to here. And we want to kind of transform that into how we define. So we're going to write, it's called a domain. So we want to create a domain, construct domain. Okay. So our constructed domain, so this is where it comes interesting. That's where we define what is the realm of the numbers that we want to map to. So in our case, we want to map from 90 to 0, right? Because those are the angles that we want. So 90 to 0. Okay, so the closest becomes 90, the least close becomes 0. Okay? Okay, so those are our rewrap numbers. So let's have a look at them and see if it comes out the way we want. Okay, so that looks pretty good. All these numbers are, as you can see, between 0 and 90. So perfect. So now what we want to do is start rotating using these numbers. So we rotate. Okay, so first thing is a geometry. So what do we want to rotate? We want to rotate our lines. So these are our lines. Yeah. Plug that into there. Okay, so you can see they're all over the place. So what we need to do now is have the angle itself. And so that is that. See, it's going a bit crazy, but we'll figure that out in a second. And this is an important one. This is a center of rotation. So you can see they're all over the place. So the center of rotation would be, again, the points themselves, because the points represent the middle. So we just plug that guy into there. Okay, so basically now they're all over the place, but that's because we're not looking at angles. We have to just tell it that we want to use degrees, not radians. Okay, so now see we have these lines. changing. So we want to get rid of these old lines because they're, so what we're going to do is we're just going to hide them. And here is our script, okay? So you can see it's changed.